Okay, so the goal of this problem is to find the derivative of this function at some point x. So what this graph is going to look like is it's going to basically be very narrow and look something like this. Okay, so it's going to be a very steep slope and it's going to be negative at the point 1/6. Okay. So if we're going to take the derivative of this, we're going to be using implicit differentiation. So we can go ahead and say y over 6 um, times normal cosine. So cosine of y over 6 is equal to 4x. Okay, so we can go ahead and differentiate both sides with respect to x. So we can say d over dx of cosine y over 6. And this will be y of x because y is a function of x is going to equal d over dx for x. All right, so using the chain rule, we have negative sine y of x over 6 times the derivative of what's in the middle. So that's going to be times 1/6 dy over dx. So you can take the derivative of y with respect to x. So you have to do that chain rule, and then that's just going to equal 4. So we can go ahead and isolate this. So what we can say is that dy over dx is equal to negative 24 cosecant of y of x over 6. And then guess what we're going to do? We're going to go ahead and plug this same y of x into here, and it's going to be negative 24 cosecant of 6 cosine negative 4x. So it's just 6 cosine inverse cosine of 4x over 6. The 6's cancel. And then now, since this is the same thing as y prime, we can say y prime at the point x is equal to 1/6. We're going to find the slope of this graph y at the point 1/6. All right. And it should come out to, if you plug in your x, it should come out to something like negative 32.2. And does that match the graph? Yes, it's a very steep slope, very high slope. And it's negative. So that is consistent with our answer.